Welcome once again to my YouTube channel. Today we look into Miro's formula. The curved mirror has a formula known as Miro's formula. That is 1 over u plus 1 over v equal to 1 over f. So this is what we called Miro's formula. Okay. Here, u means object distance. The object distance in centimeter. Okay. V means image distance, the image distance in centimeter, while F is the focal length in centimeter. Now, with this very formula, you will be able to obtain object distance, image distance, or focal length when given. Now look at. Now with this very formula, you will be able to obtain V, F, or U if anyone is asked. Now we have the mirror, like the curved mirror we treated. Then here is the pole. Maybe here is the principal focus. Here is the center of curvature. Okay. Now if object is placed beyond C, from the mirror, we have U, which is what? Object distance. This is the object distance. Okay? Then when it reflects backwards, then let's say another one hit here, it reflects backward. So here we get the image. So here we have the what? The image distance. From here to this very point, we have what? Image distance, which is V. So U is the object distance, V is the image distance. Then the focal length is the distance measured from the principal focus to the pole. So any of these could be obtained using this very formula. Now, another formula you need to get is magnification, M, which is equal to image distance over object distance. It is also equal to image height over object height. Okay, so this is another formula that you need to master well in order to be okay with calculation solving. So remember, M means what? Magnification of the image. The magnification of the image. Okay, the magnification of the image. Then V, as usual, U, as usual, representing image distance and the object distance. Then HI is image height. The image height, okay, maybe in cm or meter. Then we have HO as what? Object height. Okay. So with this, you are going to solve calculation. Then in using this very Miro's formula, there is a convention we normally consider. We have Cartesian system, we have real is positive. But here, we are going to consider real is positive in using the formula. Real is positive. Then, once we talk about real is positive, applying it to this very formula implies any quantity that is real, you assign it positive. U and the V, which we have as objects and the image, if any of them, the object distance or image distance, if the image or the object is real, you assign the what? The numerical value there positive. But if it is visual, you assign it negative. So anything that is real, you assign it positive. Anything that is visual, you assign it what? Negative. Such implies that you, okay, that is real objects, okay, and also real images are assigned positive. So real object, if U is real, then V is real, okay, then you assign it what? Positive. Then, if you have U and the V, maybe to be visual, okay? If you have it to be visual, then you assign it what? Negative. So anything that is real, assign it positive. Anyone that is visual, assign it what? Negative. Then coming to F. F is positive when you have what? A convergent mirror, which is concave mirror. Okay? For concave mirror, okay? F is what? Positive. Then F is negative. F is negative for divergent mirror or converse mirror. Okay? The converse mirror. So with this sign convention, you are good to go. Now let's apply this very formula in solving exercises. Now we have a question on the board. It reads, a concave mirror of radius of curvature 20 cm has a pin placed at 15 cm from each pole. What will be the magnification of the image formed? Now we write down the parameters first. Now a concave mirror of radius of curvature 20 cm. Radius of curvature is 20 cm. Has a pin placed at 15 cm from each pole, which means object distance is 15. So object distance is what? Is 15 cm. What will be the magnification of the image? Now we are looking for the magnification. Now from the formula we don't have R there, radius of curvature, but there is a relationship between radius of curvature and also the focal length, which we have in our formula. Now we remember that focal length is half of what? Radius of curvature. So in that very case, our focal length here now becomes 20 divided by 2, which will now give us what? 10 cm. Okay? Now, in our formula, if we are to use mirror's formula, you remember this F should now be assigned positive because the mirror here is concave mirror. Okay? Then U, that's the object distance, and it is placed before the mirror. Hence, it should be assigned positive. Now, from the formula we have, magnification is what? V over U. But here, we know the value of U, but we don't know the value of V. But we have to find the magnification. That means we need to obtain the value, we need to obtain V, right? Then we use our formula, 1 over U plus 1 over V equal to 1 over F. So at this point, we know the value of U, but we don't know the value of V. So we have 1 over U, our U now is 15, plus 1 over V equal to 1 over F. F now is 10. So we have 1 over 10. Now we look for LCM of 15 and the V, which is 15V. Then 15 into 15V we give what? V times 1 we have V plus V into 15V we give 15 times 1 we have 15 equal to 1 over 10. So first we cross multiply, right? 1 times 15V we are getting 15V equal to 10 we now times V plus 15. We open up the bracket, we have 15V equal to 10 into V, we have 10V. 10 into 15, we have 150. So if 10V should cross equality sign, it now becomes what? Minus 10V equal to 150, right? So 15V minus 10V will now give what? 5V equal to 150. Now divide both sides by 5 in order to get V. 5 into 5 we have V. 5 into 15 we have 3. So here we got the what? The image distance to be 30. Now we've got the what? The image distance. Hence our magnification now, which is V over U, becomes what? V now is 30. While U here is what? Is 15. So our magnification now is what? Is 2. Magnification has no units because it's a quantity, is a what? Ratio of similar quantities. So magnification is 2. Now let's get into another calculation. We have a question on the board. It reads, a concave mirror has a radius of curvature of 36 cm. At what distance from the mirror should an object be placed to give a ray image 3 times the size of the object? Now, solution to the question, we write down the parameters given. A concave mirror has a radius of curvature of 36 cm. So the radius of curvature is what? Is 36 cm. At what distance from the mirror should an object be placed to give a ray image? 3 times. At what distance from the mirror? Which means we are now asked to find what? Object distance. At what distance from the mirror? That's the object distance. Should an object be placed to give a ray image? 3 times what? The object. 3 times the object. So the magnification is 3. Now to give a ray image, remember the focal length of concave mirror is positive. Okay? And the focal length of convex lens is what? Is negative. But here we are told that the image will be real. And when you use convex mirror, there is no way you can obtain a real image. Telling us that what? The mirror used here is what? Is concave mirror. So here the magnification is V all over U. And we are looking for the value of U. Okay? Now magnification is 3V over U. If we cross multiply, we are getting V to be what? 3U. So we have this as the what? As the image. So image is 3 times the size of the object. So here we remember our formula. 1 over U plus 1 over V equal to 1 over F. Here we have 1 over U, right? Then plus, because we are looking for the value of U, then 1 over V. Here our V is 3U. So we have 3U equal to 1 over F. The F is half of radius of curvature, because if you remember that radius of curvature is 2 times focal length, which means focal length is what? Half of radius of curvature. And the radius of curvature here is 36. So you divide it by 2, it gives what? 18 cm. So here the focal length now is what? Is 18 cm. Now to find the value of U, we simplify. LCM of U and 3U now is what? Is 3U, right? Now U divide 3U, we have what? 3 times 1, we have 3. 3U into 3U is 1 times 1, we have 1, right? Are we there? So 1 over 18. So 3 plus 1 is giving us 4. All over what? All over 3U, right? Then equal to 1 over 18. So here we cross multiply. 1 times 3U, we give 3U. Then 4 times 18. Now 4 times 18, we have 4 times 18. 4 times 18, which gives 72, right? So we have 3U equal to 72. Divide both sides by 3. Then if you divide 72 by 3, 72 by 3, you are getting 24. Now this 24 gives what? The object distance. So if what we did was able to help someone out there, please do subscribe, share and turn on notification for others to learn as well. See you on our next class.